So let's start the pressing station. Let's start this pressing station, right? Okay, so let's start. First of all, we already know that Festo. So Festo is a company, is a famous company where they are manufacturing automation, pneumatics, industrial training devices. Festo is a very famous company, and CP factory or CP factory or CP system. CP factory or CP system means this system is used to teach different advanced concepts such as Industry 4.0, smart factory, cyber physical systems, etc. So this CP factory is a training system that is used to teach different advanced concepts. So here we can see this is what is called a press station. Press station. So the use of press station is using pneumatic cylinder, right? So using pneumatic cylinder, this unit will press one workpiece. Workpieces or back covers can be pressed onto the front cover by means of pneumatic press unit. So we have workpiece, right? So this workpiece is having back cover and front cover. Okay. So for example, this is our front cover. Okay, on the top we have our back cover. So using this pressing unit, this back cover will be pressed onto this front cover by means of pneumatic press unit. And also this will check whether the workpiece will be available or not using sensors. With the help of sensors, this will be checking whether the workpiece is available or not, and the entire system will be automatically controlled using PLC. So we need PLC to automatically control the entire system. Actually, this is one station, pressing station. We have another stations like assembly station, manufacturing station. There are different stations. So this will work with other stations plus work with Robotino also. So what are the main parts of this pressing station? First one is the pneumatic cylinder. So first one is we need a pneumatic cylinder. And the second one is press head. Okay. So press head means, for example, this is our front cover. And on the top, we have our back cover. So this back cover will be pressed onto this front cover by means of this pneumatic press unit. Work table means where we will place the workpiece. Sensor it will identify the location of the workpiece, whether the press is completed or not. So this will be detected by the sensor. Then aluminum frame, it will support the entire structure. So we will see one by one uh, details of this pressing station. Okay, first of all, let's see one simulation of zero simulation. Let's see. So this will be like this. So the workpiece will be coming like this, and then press here, and then it will go out from here. Okay, so workpiece is coming. Okay, here, press. After pressing, this will go out. So this is the video of a Cirrus simulation. So how we can start this system? The first one is we need compressed air supply. And then we need 6 bar pressure to operate this system. Check the system pressure and set it to 6 bar. Then after that, connect the power supply. Then after that, switch on the main switch of individual stations. After that, unlock the emergency switch. Then press the reset button. So repeat the same process for all other until the reset lamp goes out. We can set up the station using the HMI screen and then switch to auto mode. Repeat the process for all other stations on the production island. So this is the standard procedure. Okay, once again, check the compressed air supply and establish if necessary. Okay, and check the system pressure and set it to 6 bar if necessary. 6 bar pressure is required to operate this entire system. And then after that, check the power supply and establish if necessary. Then switch on the CP power supply units and wait for the component startup. Then unlock the off button and acknowledge the errors with the reset button. Start button switches to automatic. So alternatively, these steps can also be done via the touch panel. So unlock the off button, press the automatic button once to reset the branch, and once again to start it. Label printer and heating tunnel must be switched on separately. So repeat the process for all other stations on the production island. Okay. So let's see, coming to the technical data. So coming to the technical data. So this is the front view, side view, and top view of the pressing station. This is front view, right? This is the front view, top view, and side view of the pressing station. So in the front view, where we can see what will be the total height of this station, 523 millimeter. So the total height of the pressing station will be 523 millimeter. So the pneumatic cylinder will come and it will press on the top of the workpiece. In the side view, where you can see, uh, it looks like, L shape, right? Then in the top view, the width will be 244 millimeter and the depth will be 185 millimeters. So the size of the base will be 244 by 185. So we can use this to prepare the 3D model in Fusion 360, and also we can give a proper scale for digital twin UDF. In the URDF, Unified Robot Description format, we can set the frame size. In the gazebo simulation collision visual model, we can prepare it correctly. Using this dimension, we can place the press station perfectly, precisely in the CP factory layout because of this dimension. So finally, so keep this point in mind, 523 mm will be the height and the base dimension will be 244 width and 185. Okay, so that will be the uh, you know the overall dimension of this pressing station. Then coming to our technical data. So the power supply 24 VDC for 4.5 A safe extra low voltage PLV. Okay, so to operate this 24 voltage, to operate this pressing station, 24 voltage DC is required. And it will use maximum 4.5 ampere current. This will use. PELV means protective extra low voltage. So that means protective extra low voltage. That means this will be working safely with low voltage. So this system is working with a low voltage, protective extra low voltage. So digital input 3. Okay, so digital input 3, then output 2. That input 3 means this will receive input 3 inputs from PLC. That is the meaning. We have programmable logic controller, right? So it is having 3 digital inputs. That means the press station will receive 3 inputs from the PLC. Then digital output is equal to 2. So that means from this station it will send 2 output to the PLC. For example, press complete, cylinder extended, like that. Okay, so that is about this. Then we need a compressed air, right? Okay, as I have already mentioned, we need a 6 bar pressure. So in order to work this pressing station, we need a 6 bar pressure. That means we need a compressor, right? And the supply rate will be 40 liter per minute. So that means in 1 minute, the system will be using 40 liter compressed air. And the quality, the compressed air quality, EN ISO 85731. Pressure dew point less than or equal to plus 3 degrees Celsius. So that means moisture will be very less in this compressed air. Otherwise, it will directly affect the valve, cylinder, or rust will happen. So moisture content will be So moisture content will be less. Then coming to the ambient conditions, the operating environment will be indoor. We can use this inside building only. And the ambient temperature will be from 5 degrees Celsius to 40 degrees Celsius. Relative humidity 80 degrees Celsius up to 31, sorry, 80 percentage up to 31 degrees Celsius. Pollution degree 2, dry non-conductive contamination. Up to 2000 meter above sea level, we can use this. Noise emission less than 70 dB. So this is like our normal uh, sound when we talk. Then coming to the certification, so this was manufactured as per the European standards, Machinery Directive, EMC Directive, ROHS Directive. Then coming to the measurements, length, length will be 244 millimeter, right? And the width will be 185 millimeter, and the height will be 523 millimeter. And the approximate weight of this pressing station will be 4.4 kilogram. So in order to work with the digital twin, we need the power supply 24 voltage DC. So in order to work, this 24 voltage DC is required, right? And it will be consuming 4.5 ampere current. It is having 3 digital inputs and 2 output. And a 6 bar air pressure is required, and air consumption 40 liter per minute, and the working temperature will be 5 degrees 5 between 5 to 40 degrees Celsius, and the total dimension will be the height of the pressing station will be 523 millimeter, and width will be 195 millimeter. Sorry, width will be 185, and length will be 244 millimeter, and the total height will be 523 millimeter, and the total weight of this pressing station will be 4.4 kilogram. Then coming to the overview of the system. So in this CP factory having, uh, you know, basic modules. So we have basic module, application module, right? Yeah. If you combine this basic module plus application module, you will get the output. This is the uh, overview of the system. Let's see this one by one. Let's see this one by one. Let's see this one by one. Okay, so we have our basic module, right? So we have our basic module, right? On the top of this, we will place this application module. Okay, if you combine this application module to the basic module, this will be converted to a station. This will be converted to a station. So here we have basic module, and then we have application module, like example press. Then this will be converted to what? This will be converted to a pressing station. This will be converted to a pressing station. Okay, so now you can see this is the basic module, right? And this basic module is having a conveyor, right? So this means this is a conveyor module, right? But if you connect if you connect this pressing unit like this, okay, so this will be uh, this will become what? This will become press station, right? Press station. This will become a press station. This will become a press station. Okay, and if you so say this is station one, right? So similar to that, if you have different stations, if you have different stations, it will becomes a production line. It will becomes a production line. It will becomes a production line. If several stations are put in a row, one behind the other, this will form a production line. Okay, then we will see one by one. What do we mean by carrier? We have carrier, pallet, workpiece. So the carrier, okay, so the carrier will be a base, okay, and this carrier will be moving on this conveyor, okay. This is not a workpiece. This is not a workpiece. Okay, the carrier will be like a transport platform, and on the top of this carrier we have a pallet. So this is a fixture we will place on the top of this carrier is what is called a pallet. This is called a pallet, okay, where this pallet will be hold this workpiece properly. Okay, so the procedure will be like this. We have carrier. On the top of the carrier we have pallet, and then pallet on the top of the pallet we have our workpiece. We have our workpiece. Okay, so the working process will be like this. We have conveyor, right? Okay, so the conveyor is moving, right? Okay, in the conveyor we have carrier, and on the carrier we have pallet. On the pallet we have the workpiece. Okay, once it will reach us here, right? Then pressing operation will happen. Pressing operation will happen. After completing this pressing operation, this will go to the another station, say station number 2. So we can think about this as the the mobile phone assembly. Okay, this is a simple demonstration of a mobile phone assembly, right? So we have our front cover, we have a front cover, and we have a back cover, right? Then we have a board, printed circuit board, electronic board. And in this board, we have two fuses. This is fuse 1 and this is fuse 2. Okay, so the procedure will be like this. On the carrier, we have our pellet, and on the pellet, we have our workpiece, right? Okay, with the front cover. Inside this cover, we have board and we have back cover, right? And this will reach us here. The pressing station will press so that we will get the final mobile phone. So the job of this pressing station is to make sure that okay, workpiece is available or not. Okay, then after that this will press the front cover. Inside the front cover we will be having the PCB, and then back cover this will press with the help of pneumatic cylinder, and after that it will check whether the pressing is completed or not with the help of sensor. I hope it's clear. Okay. Then next we will see the application module press. Okay, first of all, what is the main objective of this module, right? So that the job of this station is to pressing a front cover and back cover together. Okay, so we have front cover, then inside this we have PCB board, right? We have back cover. Okay, so the job of this station is to press the front cover with back cover so that we will get the final output. Okay, so as I have mentioned previously, okay, this is a simplified version of a mobile phone. Okay, so doing this you will be learning how to assemble a mobile phone. Okay, let's see what are the main parts of this system. Let's see what are the main parts of the system. So this number 1 represents, this is what is called a input output module. This is what is called a input output module. Okay, so this will be communicating with the PLC. Okay, and this will collect information from the sensor. This will be collecting information from the sensor. Okay, and then those information will be sent to the valve. Okay, for example, start signal, press complete, sensor status, etc. Then we have number 2. Number 2 represents the valve. Okay, so this is what is called a valve. Okay, first of all, this is what is called input output module. Okay, and below that, uh, below the input output module, we can see the valves. This is pneumatic solenoid valve. So the job of this valve is to open the compressed air, open close the compressed air, so that the cylinder will move forward and backward. So that is the job of this valve. Then number 3, we have one-way flow control valve. This is what is called a one-way flow control valve. So From the name itself, it is one-way flow control valve. Flow control valve means this is to control the flow of the compressed air. Okay, so yeah, we have one-way flow control valve. This is to control the flow of the compressed air. This one-way flow control valve is to control the flow of the compressed air. So we have input output module. This is our input output module. Below that we have valve, and then we have one-way flow control valve. Then we have our pressing cylinder. This one. This is our pressing cylinder. This is the main part of the pressing station, where uh, where this pneumatic cylinder will move downwards and press the front cover PCB with the back cover. Then number 5 is the workpiece request. Okay, so this will be requesting conveyor uh, that to send the workpiece to the pressing station. Okay, so this is what is called a workpiece request. Then we have a light guide unit, number 6. This is what is called a light guide unit. So this is actually an LED indicator. Okay, if this will glow, that means pressing station is requesting a new workpiece, so that the operator can understand, or the next station can understand that, okay, this pressing station is requesting a new workpiece. Okay, so the procedure will be like this. So the first of all, PLC will start. So the PLC will communicate with the input output module, right? Then based on that, this valve will on, then compressed air will be coming, right? Okay, then here pressing will be happening, and then after that, uh, okay, once this is completed, then this workpiece request signal will request a new workpiece, so that the conveyor will uh, uh, transfer the conveyor will give the next carrier to the pressing station. So this is the procedure of this station. Okay. So here this is discussing about the sensors, proximity sensors used in the pressing station. Here we have two proximity sensors. One, two. So this pressing station is using two proximity sensors. So this will be used to locate the sensors, the position of the cylinder, and then it will send the signal to the PLC. So we have two proximity sensors. One is BG1 and another one is BG2. Proximity sensor SMT8MA PS 24 volt E 2.5 OE. The part number is 574335. The source identifier BG1. So the use is lifting cylinder upper position. Okay, so this will identify whether the cylinder reaches the retracted position. Okay, if the sensor is on, okay, then the PLC will identify. If the sensor is on, then the PLC will identify, okay, cylinder reaches here. Then we have proximity sensor BG2. So next is proximity sensor BG2. Proximity sensor SMT8M APS 24 volt E 2.5 OE. Part number 574335 BG2. And the use is press position reached. Okay, so that means the cylinder will be moving up and the cylinder will be moving down, right? Lifting cylinder per position reached. Okay, if the cylinder reaches here, then this sensor will detect, okay, on, then share this information to the PLC, right? Okay, if the cylinder reaches here, press position reached, okay, that means the cylinder moves downwards, whether the cylinder reaches the below position or not. Okay, if the sensor turned on, then PLC will identify, okay, press operation position reached. So these two sensors are magnetic proximity sensors. Okay, so the working will be like this. Okay, when you press the start button, so the working will be like this. When we press the start button, right? Okay, then this valve will on, right? Okay, then the cylinder will move down, right? Okay, and then what happens? BG2 on, right? That means cylinder reaches downward. Okay, then pressing operation completed, right? So pressing operation completed. Okay, that means cylinder moves upwards. Then BG1 on, right? Okay, so BG1 on means pressing completed, right? That means cylinder will be in the upper position, right? So the cycle complete. So we have BG1. Okay, please understand this. We have BG1 and this BG2. Okay, so whether this cylinder reaches the top position. Okay, so this sensor will communicate with the PLC that this cylinder reaches the top. Okay, and or whether the cylinder reaches the bottom. Okay, if the cylinder reaches the bottom, okay, so BG2 will communicate with the PLC. Okay, cylinder reaches the bottom. Okay, so here this is BG1, right? And bottom this is BG2. Okay, so BG1 on means cylinder is ready. So BG2 means cylinder reaches the press position. So we can start the next section. So next is we have light guide sensor. Okay, so here this light beam, this red represents, this red line represents, this is a light beam actually. Okay, so this light beam having in one end it is having a transmitter and another end it is having a receiver. This is a through beam photoelectric sensor. So number one, we have light guide, this one. Number one, this is the light guide. And part number 552812, the source identifier BG8. So the light will reach from here to here. Okay. And it will check whether the workpiece will block the light beam. So this will be checking whether the workpiece will be blocking the light. Okay. Then we have a light guide unit. This one too represents the light guide unit. Part number 8127556. Resource identifier BG3. Okay, so this will be receiving and sending, light guide unit. Okay, if this light beam is broken, okay, if this light beam is broken, then immediately this will send a signal to the PLC. So immediately this will send a signal to the PLC. If the light beam is broken, then immediately this will send a message to the PLC. Okay, so for example, so the working is very simple. Okay, so if light is reaching, okay, if the light is reaching, that means sensor off, right? So that means there is no front cover, right? So if there is a front cover, what will happen? That front cover will block the light beam. Okay, if the light beam is blocking, then the sensor will turn on. Okay, So that means the workpiece is reached here. So the job of this sensor, so the job of this sensor is to identify front cover. Okay, so the job of this sensor is to identify front cover. So we have BG8 and we have BG3. If BG3 on, right? So if BG3 on, that means front cover is available. So if front cover is available, then we can start the pressing operation, right? Allow press. Okay. If BG3 on, we can start the pressing operation, right? If BG3 is if BG3 is on, we can start the pressing operation. We can start the pressing operation. That means front cover is available. We can start the pressing operation. If BG3 is off, if BG3 off means there is no front cover, don't start the press. Okay, so the carrier is coming, right? So the carrier with the pallet with the workpiece is coming, right? So then this BG3 is checking, okay, whether a front cover is available or not. Okay, if the front cover is available, yes, then press. If front cover is not available, then wait. This is the working procedure. So this is what is called a input output module, part number 8027412. So this is the main control. This is the main control module. I will show you here. Yeah, this one. This is what is called a, uh, input output module XD1. Okay. Yeah. Here this is input output. So I represents input and O represents output, right? So we have PLC, right? We have PLC, right? Okay, and we have our pressing station, right? So this module will be communicating between the pressing station and with the PLC. So this module is uh, communicating with the PLC and the pressing station. Okay, so simply we can say, so let's say this is our pressing station and we have PLC, right? So we can say this is the brain. So input output unit is the brain of this pressing station. This is the communication interface between the PLC and the pressing station. So what are the main jobs of this input output module? Okay, so we have mentioned we have different sensors, right? Right, we have BG1, BG2, right? Okay, we'll write here. So we have BG1, BG2, right? Then BG8, BG3, right? So BG8, BG3, right? Okay, so we have different sensors, right? Okay, so this will uh, receive inputs from the sensors, right? Okay, and also this will give output to the uh, sorry, output to the devices, right? Solenoid valve, plus cylinder, indicator light, etc. Okay, here in this screen we can see this is what is called a 24 VB. This represents 24 voltage power supply. Okay, okay. So if this light is turned on, that means this is receiving electricity to operate, right? To operate this need a 24 voltage power supply, right? Then 24 VA, that shows the input output. So this the second one shows whether the input output is working or not. If the LED is on, that means this module is ready. Okay, the second 24 VA is the use is that whether the input output is properly working or not. If the light is not turned on, that means this is not turned on, means it is okay. Working is okay. Okay, so the working will be like this. So we have PLC, right? Okay, I will write here. So we have PLC, right? So PLC is communicating with this input output module. Okay, so this input output module will receive data from the sensor, right? Okay, and then output will be shared to the valves, right? So finally, uh, the input output module XD1, this part is communicated with the PLC and with the pressing station. Okay, it will collect data from the sensor, and then based on this data it will take appropriate decision, and it will send output to the valve or cylinder so that we can control the valve and cylinder. This will be receiving 24 voltage. So 24 VB LED means this is receiving 24 voltage current to operate this, and the 24 VA represents the input output module is ready. That means this module is ready to collect data from the sensor, and it is ready to share the output to the valve or cylinder, etc. Okay. So next is what is called a pneumatic. So this is the first solenoid valve. Okay. So first solenoid valve CP10 series. Okay. So what is the job of this valve? Okay, as I have mentioned, we need 6 bar pressure, right, to operate the system. Okay, this will be controlling the 6 bar pressure, and this will be moving the cylinder upwards and downwards. So the details of valve will be CP10M1BH3GLM7 and the part number 196915. And this valve is used to move the cylinder upwards or downwards. This is used to control the cylinder. So we have two positions, MB1 and MB2, right? So what do you mean by MB1? Resource identifier MB1. That means lifting cylinder upwards. Okay. If MB1 on, then what will happen? Solenoid valve will work. Compressed air will move to one side of the cylinder. Then the cylinder will move upwards. Cylinder lifting cylinder upwards. Okay. Then position 2, that means MB2, that means lifting cylinder downwards. If MB2, if this, if PLC, if PLC will turn on MB2, solenoid valve will activate, air cylinder will go to the other side, and then cylinder uh, will extend and completed the pressing operation. Okay, so we have MB1 and MB2. So MB2, if MB2 is on means cylinder will be moving downwards, right? Then pressing will happen. Then BG2 sensor on, right? Then after pressing, then MB1 on, right? Then the cylinder will be moving upwards. Then BG1 sensor on. Okay, so the complete cycle will be like this. We need compressed air of 6 bar pressure required, right? Then we have our valve. Okay, in this valve, okay, in this valve we have position 1 and then position 2. Okay, so this is MB1, right? And this is MB2. Okay, so MB1 means cylinder up, right? And MB2 means cylinder down. Okay, so next is what is our lifting cylinder. And model DFM 1210 PAGF, part number 170824. This is the main actuator. This is the main actuator of the pressing station. This is the main actuator of the pressing station. So what is this lifting cylinder? Okay, so we have our compressed air, right? Okay, so using the compressed air, okay, so this will be moving up and down. Okay, linear motion, and this will be moving and move the press head and press the workpiece. So this is having main parts such as cylinder body, piston rod, air ports, magnetic piston, etc. Okay, so the working will be very simple. If so, okay, PLC started, then MB2 on, okay, then compressed air will engage the cylinder, so the piston will be moving down. Press head will press the workpiece. Okay, immediately BG2 will turn on, right? BG2 will turn on. So after pressing complete, PLC MB1 valve on, compressed air on the other side, cylinder will be moving on the top up, and BG1 on. Okay, so what is the, so here you can see DFM 12 10 PAGF, right? So DFM means guided pneumatic cylinder. Of the bore diameter will be 12 millimeter and 10 will be the stroke length. So that means the cylinder will move approximately 10 mm distance. And P is the pneumatic version. So AGF, this is the special configuration code of Festo. Okay. Okay. Next, we are going to discuss the one-way flow control valve. One-way flow control valve number one. Okay, this one. One-way flow control valve GRQS3. Then number two, one-way flow control valve GRQS3. And the model number GRQS3, part number 193965. Okay, so this will be controlling the compressed air, the flow of compressed air to the press cylinder. This is a special pneumatic valve. This will be, so the main positive of this is air will be moving in one direction only, and in the other direction it will restrict the flow of the compressed air. So this will allow to flow the compressed air in one direction only. That's why this is what is called a one-way flow control valve. This position one is representing valve one, right? And this is the second one, position two. This is position one and this is position two. So why this flow control valve is required? Because the cylinder will uh, move very quickly. Okay, so if the cylinder is moving very quickly, it will create huge impact to the workpiece, right? So that will damage the workpiece, right? So very huge impact will be produced, right? So pressing operation will not happen properly. So we have to control this flow in order to make sure that the pressing operation will be very smooth and accurate. So if the flow control valve will be there, so the cylinder will move very smoothly, and we can control the pressing force, and and also the life of the system will increase because of this. Okay, so I have already mentioned what is the job of the pressing station, right? So the main job of the pressing station is to press the front cover and back cover. So the process will be explained here. Okay, so through the conveyor, uh, the workpiece will be reaching pressing station with the help of carrier, right? Then we have light barrier photoelectric sensor. If the if the, if the workpiece is coming, it will break the light beam, right? If if the light beam is broken, okay, then immediately the sensor will turn on. So then the PLC will understand, okay, workpiece is available, carrier will stop, pneumatic press will unit will move downwards, and it will press the front cover and back cover, so that pressing operation will be happening. After this, pressing unit will move to the upside and carrier will move to the next station. Okay, so start conditions, the sequence description, start conditions. So before starting the operation, make sure that all electrical connections are proper. All connections are established properly, and make sure that the pneumatic air connection is correct. PLC communication is correct. Then start position. See this arrow. The pressing unit must be without pressure in its upper end position. That means press head will be on the stop. Do not press the workpiece. It will be ready to receive the new workpiece. Okay, so the procedure will be like this. So carrier will reaches the pressing station and crossing the light barrier. So light barrier will identify the workpiece. Immediately carrier will stop. Automatic pressing operation will happen. So valve MB2 will turn on. Compressed air will engage the cylinder. Cylinder will move downwards. BG2 sensor on. Pressing operation will happen. It will assemble the front cover, PCB and back cover. And after that, cylinder will be moving upwards and valve MB1 on, BG1 sensor on. After that, carrier will go to the next station. Conveyor will work again, release the carrier, then it will go to the next station. Okay, so this is showing the electrical connections. So in order to operate this pressing station, we need to connect the electrical connection. We need to provide electrical connection to this system, right? So we have to connect this with the electric board of the basic module. So this is our input output module, right? Number one, this is our input output module, right? And it is connected to the input output terminal 2 on the basic module's electric board. So this is the electric board of the basic module. So we should connect the input output module of the application module to the input output terminal on the basic module's electrical board. So through this power supply, that means 24 voltage, DC, sensor signals, valve control signals, PLC communication, everything will be happening because of this. Then input output connections. So this is our application module, right? So this is our application module. This is the input output module, and this is the electrical board of the basic module. We have to connect this to the input output terminal. Okay, so this means from the pressing station, from the input output module through this cable, okay, it will be connected to the basic module electrical board. Okay, from here it will go to the PLC. First go to the board, then go to the PLC. Okay, here this represents the input output module. On the top, where you can see the on the top of the pressing station, we can see the input output module XD1. So it will receive signal from the sensor, right? Receive valve commands and share all those commands to the send this to the electrical board through this cable. Okay, from here it will go to the PLC. Okay, so this is application module. This is our basic module. Okay, so where we can see the input output terminal on the electrical board. This will be inside the control cabinet. Here we can see the PLCs, input output terminal, power supply, communication modules, etc. Okay, so we have our pressing station, right? In the pressing station, we have different sensors such as BG1, BG2, BG3, then MB1, MB2, etc. Right? Then all these informations sent to the input output module XT1. Then through this cable, it will be connected to the basic module electrical board. Okay, and then from here it will be transferred to the PLC, where we have the PLC program. It will execute the PLC program. Okay, so next we will see the input output box XD1. As I have already mentioned, this input output box XD1. Okay, so we have our pressing station, right? Okay, so in the pressing station we have sensors, valve, etc. Right? Then we have our PLC, right? So this is having input and output, right? Okay, so what do you mean by input? Input means from here, from the pressing station, this will go to the PLC. So input means input. Input represents this will be the input to the PLC. So output. So this input means input to the PLC. So output means this is the output from the PLC. That means from PLC to the pressing station. That is what is called output. Okay, so let's see what are the inputs. We have BG1 and BG2. So BG1 means cylinder top, right? BG2 means cylinder down. So the equipment identifier will be BG1, right? So what is the job of this sensor? So the job of this sensor is to identify whether the cylinder reaches the top position. Okay, if the cylinder reaches the top position, this sensor will communicate to the PLC that this cylinder reaches the top. So XD1 slash XK I0, syslink XD1 XX30, then BG2, press position reached. So equipment identifier BG2. So what is the job of this? Once the cylinder reaches the press position, okay, this sensor will communicate to the this sensor will communicate to the PLC that the cylinder reaches the bottom position. So the XD1 slash XKI1 syslink XD1 SK14. 0, 1. Okay, then 2, 3, 4, 5, 6, 7. Okay, so these inputs are reserved, not using. Okay, we can add more sensors. Now we are using only 2 sensors. In future we can add more sensors. So these are the inputs we can use. Then what do you mean by BG8? So BG8 means front cover is available. So light barrier sensor will locate the front cover. So PLC input address XD1 slash XKI7 syslink XD1 XS20. Then, so I have mentioned we have PLC, right? So this input means to the PLC, to PLC. So this output means from the PLC to the pressing station. So what are the outputs? First one is MB1. MB1 means cylinder up, cylinder up. So solenoid valve will operate and move the cylinder to the up. XD1 hash XK00 O0 syslink XD1 XS1. Then MB2. This is up, down. MB2. So in order to move the cylinder, it will activate the solenoid valve XD1 hash XK01 syslink XD1 XS2. Then again we have 2, 3, 4, 5, 6, 7. So these you know uh, these outputs are not using same to the inputs. In future we can use this as alarm indicator, or we can connect any other actuators. Okay, then coming to the assembly procedure. So here, one of the main important measurement was this 33 millimeter. So the conveyor stop edge, right? So from the conveyor stop edge to the press module frame, the distance will be 33 millimeter. Okay, so we have the press, see, we have the stopper. So from the stopper to the press module frame, the distance will be 33 millimeter. Then only the carrier will be in the correct location, so that during the pressing, the workpiece will be in a proper position. Alignment will be perfect. So this is the requirement. So the distance from the stopper to the press station frame, this distance will be 33 millimeter. Okay, so next is the assembly. Next is the assembly of CP application module to the, so this is our CP application module, right? To the, this is the conveyor. First, put the slot nuts or T-nuts into the aluminum profile of the conveyor. Put the two slot nuts on the front inner slot, and put the back uh, two slot nuts on the back inner slot, and move the press station so that it will be properly aligned with the frame. And after that, on the top of the profile, using bolt, assemble the press station properly. So here, yeah, this one is the back cross profile, right? And the second one represents the here slot nut. Okay, number two, this is the enlarged view of number two. Number three, inner slot. Number four, uh, three and four, inner slot. One is back cross profile and another one is front cross profile. Number five is the front cross profile. Then after that, place the press station on the top of this conveyor, on the top of this aluminum profile, right? Then align the slot nuts properly. This one is called a mounting bracket. And yeah, this is what is called a mounting bracket. and 2 represents the slot nut. You should use the Allen key for lateral adjustment of the slot nuts. Using Allen key, we can move the slot nut either left or right so that we can place the slot nut properly. Okay, so next is the press station alignment. So raised head screw, using raised head screw, connect the press station temporarily. Do not tight the screw now. Then after that, move the press station forward and backward and make sure that the alignment is correct. Check the front cover sensor is correct or not. Front cover should be inside the sensor point. Check the distance sensor alignment. It should see the front cover, don't not carrier. If the alignment is correct, then tight the raised head screw. Finally, place the black cover on the top of the mounting bracket. So this number 1 represents the uh, mounting bracket with cover, and number 2 CP lab conveyor cross profile. So this is the final assembly of the pressing station. So this is the press, this is the application module, and this is the base module. If the application module is connected to the base module, then it will be converted to a station. Here it is what is called a pressing station. Okay, so CP application module input, this is the input output terminal, right? And then this is the analog terminal. And number 3, this is the connecting cable with a syslink plug. Then number 4, connecting cable with a 15-pin standard D sub plug. Number 5 is the basic module board. And number 6 uh, PLC. Number 6 represents the PLC. So next is our pneumatic connection. Pneumatic connection means how we can give the compressed air into the uh, pressing station. So in order to operate this system, we need 6 bar pressure. So here, this this blue tube, right? So this is air hose. So through this air hose, so we have compressor, right? So we have compressor, okay. So from the compressor, it will reaches compressed air reaches here. Then through this air hose, the compressed air of 6 bar pressure will go to the pressing station. So this is what is the hose, or this is the air tube. This is our hose or air tube, and the dimension is 4 mm. So the duty is to transfer the compressed air to the pressing station. Then we have number 2 is what is called a shut-off valve. So this shut-off valve will on or off the air supply during the maintenance time. So during the maintenance time, we can cut this airflow using this shut-off valve. Then we have T-plug. This is to split the airline. Okay, we can split the airline and we can give air supply to different modules using this T-plug. Then we have T connector. So we have different hoses, right? So the connector is used to connect the hoses, and the air supply we need 6 bar pressure. This is the main line from the compressor. So before starting the pressing station operation, turn on the compressor. Pressure should be 6 bar. Make sure that there will be no air leakage. So this blue tube is perfectly working. Shut-off valve is check the shut-off valve either on or off. So this is the assembly of CP application module to a CP factory basic module. We have already discussed that. Again, this picture is also showing that how we can connect the application module to the base module, right? So put the slot nut, then place the press station properly on the top of this base station using mounting bracket. Check the alignment is correct or not. And after that, we have to check the alignment, right? We have to check the alignment of this application module to the base station. Next, coming to the electrical connection. So there are two types of electrical connection. One is syslink interface digital signals. This is to share the digital input output signals. For example, we have BG1, BG2, BG8, MB1, MB2, etc. So all those signals will be uh, sharing through this syslink cable. Then we have D sub interface called analog signals. So we will be getting signals from the distance sensors. To transfer those signals, we will be using 15-pin D sub cable. So we have two cables. So D sub cable and another one is syslink interface for digital signals. So number one is input output, right? Terminal, right? Then number two, this one analog terminal. Number three, this one connecting cable with a 15-pin D sub plugs. Then number four is what is called this one. This is the electric board, CP factory basic module, analog terminal. Then number five is the connecting cable with the syslink plug. Then number six is the electric board CP factory basic module. Okay. Then coming to the pneumatic connection. In order to operate the pressing station, we need compressed air, right? And we need a 6 bar pressure required. So we have, pneumatic hose, right? This blue air tube. This is what is called a pneumatic hose. So through this, compressed air will be reaching to the pressing station. Then we have a shut-off valve. Okay, this is to turn on or off the air supply. This is during the maintenance. Then we have T plug that is used to split the air supply, and we can use this for another stations also. Next is adjusting the sensors, right? How we can place the light guide sensor using workpiece front cover. Okay, what is the use of light guide sensor to check workpiece front cover is available or not? So this is actually an optical sensor system. This is to check whether the front cover reaches or not, and also checking workpiece is properly placed or not. This red color, red line represents this is what is called a light barrier. Okay, so we have number one, this one. This is number one, right? Light guide, and we have number two. This is called a light guide unit. So this light guide unit will create the light and receive. So this is a sensor unit actually. This is a sensor unit to create the light and receive. This is a sensor unit actually. This light guide is a fiber to transfer light. So here the working will be like this. Okay, this is our light guide unit, right? Okay, so this light guide unit will send a visible infrared light beam. Okay, if there is no workpiece, okay, then the receiver will receives light. If a workpiece is here, okay, then light will be blocked here, right? So receiver receives no light. Okay, so the workpiece will block this light. Okay, immediately the sensor will identify that okay, workpiece reached because the light is blocked, right? Okay, so this light guide unit we need to install first. Okay, electrical connection should be proper, power supply is proper, transmitter, receiver, light guide heads, everything should be in normal location. Light guide units connect this to the fiber cables using the screwdriver. Adjust the screws till LED light will coming, right? And also place one workpiece on the in the front of this barrier, right? So immediately LED will off. That means the sensor will be properly detecting the workpiece. So repeat the same procedure for all the light barriers. So this is very important. As per the manual, they are saying that the the maximum turns when you apply on adjustment screw should not exceed 12. Okay, so next is our proximity sensor or cylinder pressing unit. So the cylinder will be moving up, down, right? Okay. If the cylinder is moving up and down, we will be using this proximity sensor to locate the cylinder's current position, whether the cylinder is on the top or whether the cylinder is on the bottom. Okay, this is a magnetic sensor. Okay, so we have upper position, right? So for upper position, the sensor is BG1 and we have down position BG2. Cylinder upper position and the cylinder position, proximity press position reached. So if the cylinder up, then this will turn on, right? Okay, then this message will be communicated with the PLC. Then if the cylinder is down, then BG2 on. Okay, that means if BG2 on means the system will understand, okay, pressing completed. So next is the adjusting the one-way flow control valve. So this is to control the flow of the compressed air. Okay, that means we can control the speed of the compressed air. How? So we have our cylinder, right? So cylinder is moving up or down, right? So by adjusting this flow, by adjusting this airflow, we can control the movement of this cylinder. That is what is the use of one-way flow control valve. So this number one, this is one-way flow control valve. Cylinder will control the airflow in one particular direction, and number two will be in the other direction. Cylinder, the airflow, control the airflow in the opposite direction. That means, for example, cylinder is in up, down, right? Okay, that means cylinder is having upstroke and another one is downstroke, right? So to control this movement of the cylinder, we can use this one-way flow control valves. So before doing the adjustment, pneumatic connection will be proper and compressed air should be 6 bar pressure. So the procedure will be like this. Okay, first close. Okay, first we have two valves, right? Close the two valves completely clockwise. Close means clockwise. Okay. And after that, uh, counterclockwise, one valve, one turn. Then do a test run. Okay. If the cylinder is moving very fastly, then close the valve little. Okay. If the cylinder is moving very slowly, then open the valve little. So like that, till you get the required speed, you have to adjust this valve. So a proper speed is required, right? For example, if this is the cylinder and this is our workpiece, right? So if the cylinder movement is very fast, okay, it will create a huge high impact on the workpiece. So the workpiece will damage. Okay, machine vibration will increase. And another problem is that if this movement is very slow, what will happen? The number of products we are going to produce, the number will be very less. That means the production cycle time will increase, right? As far as industries, we need more number of products, right? With a limited time, right? So productivity will decrease, right? So we need a proper speed so that we will get maximum output without any damage to the workplace. So we have to adjust the speed properly. Next, we are going to operate the pressing station. So we will control the pressing station using the HMI. HMI touchscreen. That means human machine interface touchscreen. So in the HMI home screen, we have different modes. So for example, operate mode, then overview. So overview will give you the system status. Then we have user. This is related to the user settings and input output test. So we have inputs and outputs. Then finally we have our process informations. So centrally we can see our reset button, automatic button, setup and a cycle end. If you are doing maintenance, we can use setup button. So after that, setup mode will active. After that, we can test individually actuator and a sensor. So go to the setup mode, right? Okay, so go to setup mode, right? Where you can see the input and outputs of this press module. Okay, so here we have MB1 and MB2. So MB1 means cylinder up, MB2 means cylinder down, right? MB2. So we have MB1 and MB2, right? So MB1, so MB1 lower, right? MB1 means cylinder down, right? Sorry, MB2 cylinder down, MB1 lift, right? MB2 lower, MB1 up. Then input sensors BG1. BG8 means is available. Yes. So here we have three options, right? Application, belt, and stopper. If you are going to check the press, select this application option. Then we have two buttons, up, down, right? So up, down. So up means MB1 and down means MB2. So if you press up, what will happen? So the cylinder will move up, right? So press cylinder will move up. If it reaches on the up, then BG1 will activate. The sensor BG1 will activate, right? Let's see. So here we have two options, right? One is up and second one is down, right? So if you press this up, what will happen? The cylinder will go up, right? Then it will activate the G1 sensor. Then if you press this down, the cylinder will go down. This will becomes green color. Then BG2 will now. So now you can see. Now the cylinder is up, right? Now the cylinder is up, right? Okay. So now the cylinder is up. So BG1 is activated. But if you press this down, it will go down. BG2 will activate. I don't know what is the reason. Then this BG8. So this BG8 is what is called a light barrier. This BG8 is what is called the this is called a light barrier. This BG8 is called a light barrier. Okay, so that means it will detect the front cover. Okay, so let's see. Move to application. So see this BG8. So now I am moving this. Okay, so this is the light barrier. Yes, the sensor. So the sensor BG8 detected the this color because because this light bulb, this is actually a sensor. This is called a light bulb. Yeah, it comes in BG8. This BG, this BG. Right? So this will produce a light. So one is transmitter and another one is receiver. So there is a light. So continuous light is going on. Right? Yeah, so you have to put your hand. That means like uh, it will break. The, it's a continuous beam, right? So if you place your hand like this, so it will break. So it will break means so input will be activated. So if this is activated, a message sent to the PLC that okay, front cover is there, then press. So PLC will give a message. So as per the PLC program, it will the cylinder will go down and press the cover. Okay, so let's see one by one. So let's see, let's check one by one, right? Okay, if you press this up, then cylinder will go up. So then this BG1, you can see this BG1. Then if you press this down, then it will activate this BG2. Okay, if you place the workpiece, this will activate BG8. BG8 will turn on. Okay, let's see one by one. Okay, go to application. Now this is okay. So this is now I'm going to lower, right? But this BG2 is not activating. So that means there is a problem. This BG2, there is a problem. So lift, okay. Now the cylinder is up, BG1 is activated, right? So lower, BG2 is not activated. Okay. Then next time moving the workpiece. So this is the front cover, right? Okay. So the sensor BG8, this will detect. This is BG8, this is BG8. So this sensor will detect whether the workpiece is available or not. This is a light beam actually. If you place your hand like this, see, like this. That means this will break, your hand will break the path of the light beam, right? So immediately you can see an input signal reaches here. So this means the light. That means something is here. Okay. In this case, this is a workpiece, right? If I move this, it will I'm moving this. So for instance, of this camera, so this application. Now now BG8 sensor BG8 is activated, right? See, see, see. Now BG8 is activated, right? Now this BG8 is activated. See, see now this is lower BG2 is activated. Okay, that means pressing is completed, right? So, Next is transitions of the application module. Okay, so these are the parameters to arrange the automatic sequence. So these are the parameters. These are the parameters. So these are the parameters. So these are the parameters to set the automatic sequence of the of this bus module. So we will see what are the different options available here. Okay, so we have a number, right? We have a number, then start condition, application execute, then press time, press time, parameter, then end condition. So here this end condition is 4, right? Then step number 1, start condition 0, right? Press time 3 seconds, end condition 1. Then step 2 to 10, default value 0. Okay, enabled. So during the maintenance, no need to change this. In order to change the press time, or if you want to make a special process sequence, or during the first programming or commissioning time. Next is the process of application module. For this application module, there is no page available at the HMI. So next is the parameter, MES parameter. Parameter 1 is pressing time. Parameter 2, 3, 4 is not using, right? For MES4 operation, operation number 110. Parameter 1. So for MES operation, the operation number is the operation number is 110 and the parameter is 1. Description, pressing time, minimum 0 second, maximum 120 seconds, default value 5 seconds, type changeable. See next, the details of error on the HMI screen. We have 3 different types. Okay, class 0, class 1, and class 2. So class 0 means red color. So if the error color is red, then immediately program will stop. We have to rectify the fault and restart the station. Then class 1, again red color. Once the existing cycle is completed, station will stop. We have to acknowledge the fault and we can continue. And third type will be class 2 yellow. Program will continue. If the fault is okay, error will change. The error is automatically acknowledged. Coming to the interactive error window. If an error is coming, so HMI will give 3 options. Repeat, ignore, abort. So the HMI will give you 3 options. Repeat, that means you can try again. Ignore means you can avoid the error and you can continue. Abort means you can stop the existing process. Okay, so let's take this one 5009. What is this? No workpiece on pallet detected. Okay, so check pallet or check sensor BG1. So press station, no workpiece. You have to check the sensor BG1. Coming to the spare part list. So in this station, we have sensors, right? So we have sensors BG1, BG2, and BG8, right? One more, BG8. So BG1 lifting cylinder upper position, BG2 press position reached, BG8 front cover available. Then we have solenoid valves, MB1, MB2, cylinder up, cylinder down. Then pneumatic components, one-way flow control valve, lifting cylinder, input-output module, XD1. So these are the parts related to this pressing station. So this is a very important flow chart. Okay, so from this flow chart, we can understand how the PLC logic is working. Okay, so first initialize the module, right? Okay, S1. Then S2 initialize application. All outputs will reset. Start conditions will be ready. Then T2 auto. So T2 auto means this will be waiting for automatic command. So module will go to if uh, if we are using the auto mode, right? So the system will be waiting the auto mode, right? So then the module status will be changed to busy because this is in automatic mode, right? Okay. Then check all the sensors as for sensor check. Okay, if any sensor error will be there, then HMI will give you, a message. Then S6 move down. So S6 move down means the cylinder will go down, right? Okay, it will move till BG2 will activate. Okay, then pressing time is 5 seconds, right? Processing time is 5 seconds time, right? Then after that, as it move up, then MB2 off, cylinder will move up. Then S2. S2 means cycle will go back to the ready state. Cycle will go to the ready state. Okay, so this is the auto mode, right? Okay, and this is the reset. This is during the machine reset. Okay, so the system is waiting for either auto or reset. Okay, if you press the reset, okay, so the system will receive the reset command. Okay, then S23, so machine will busy, ready signal off, then reset procedure will start, then reset up. Okay, so cylinder will move up home position where we can move the cylinder on or off, up or down. It will check the initial position to check whether the home position reached or not. Then finally T26, no operation. Okay, machine will be going to the ready state. S2 means again it will go back to the initialization step so that we can start the auto operation. Okay, then coming to the MES4. Okay, so now I am going to open the MES4 master data. Then go to resources, right? Then there I am selecting the press. Okay, then I am selecting press. Press means pressing station. So 7 CP F press. On the left side, we can see all the resources, right? For example, this represents the automatic storage. ASRS represents the automatic storage. And then RASS. This means the robot assembly station. And then we have FCAM. This represents the camera station. And then linear. So linear represents linear conveyor. Now I have selected this one, pressing station, and here you can see the ID. Okay, so this is the number. Okay, this storage station is number 1, robot assembly station is number 2, camera station is number 3, like that. So every resource is having a specific ID, and this ID is what is called a 7. Okay, and then here you can see the name. So name is CP Cyber Physical. First F represents Festo Press. This is the name of this station, and the IP address. And the IP address of this is 172.21.7.1. So this is the IP address of that particular station. This is the IP address of that pressing station, 172.21.7.1. Okay, so I have pinged this one. See, ping 172.21.7.1. Okay, so network connection is correct. So send 4, received 4. So the network connection is okay. Then the PLC type. So the PLC type is Siemens. PLC type is Siemens. So this press station is using Siemens PLC. And the description, CP factory straight base with the pressing application. So it is showing that this this is a press module. Okay, and then web page 172.21.7.1. Okay, if I'm going to, okay, let me check 172. So 172.21.7.1. Then we have a buffer. So buffer means now buffer configuration is given. Then coming to the operations. Okay. So this is the operation number 110, right? And the description is pressing, and the working time it will take 5 seconds time. Okay. If you send this operation to the press station, then the cylinder will go down and it will wait. It will press 5 seconds, and after that cylinder will go up, and then after that you will get a message that cycle completed. Then we have electric energy 0 watt hour. So the electric energy is not configured, and compressed air. Okay, this also is not configured. Then coming to the topology. So topology here represents P1. Okay, so this station is having one position. Okay, so that means so this means pallet will enter here, then it will go to the next station. Okay, manual workplace type nothing. So no manual operator manual intervention is required. This is completely automatic station. Then coming to the resource position 1, this press station is having only one working position. See, this is the IP address of our pressing station 172.21.7.1. So this is the IP address of that pressing station. So this is the PLC. This is the PLC to control your pressing station. CPU. What is that? (1512 SP). Fail safe. Then Profinet communication. And the project name CPF. Station name is PLC Linear 3. Module name PLC Press. Module type CPU 1512 SPF. Operating mode is run. Status OK. Mode selector run. EWR LED. So this means PLC is getting power. Run indicator on. That means PLC scan the logic, right? In the left side menu, we have our start page, diagnostics. Then we have diagnostic buffer. So whatever errors this PLC experienced, those errors will be here. This is the main part of the troubleshooting. Motion control diagnostics. Module information. Alarms. Communication. The network status, Ethernet, Profinet communication, etc. Then topology. PLC variables, input, output,